Okay, let's try doing some separation of variables problems. This is the worksheet separation of variables fun, because doing this is sort of fun. So here we've got an ODE in the standard form, and we can see it's a product of something involving only x times something involving only y, right? So this is 1 minus x squared times 1 over y squared. All right, and now what we're going to do is we'll divide by 1 over y squared to get all the y's on the left and then all the x's on the right. So divide by 1 over y squared. Notice that 1 over y squared is never 0, so no trivial solutions are possible here. So what do we get? We divide by 1 over y squared, and we'll find out that y squared dy dx has to be equal to 1 minus x squared. Now we'll integrate both sides. This was called the separation stage. Separate. 2 is integrate. And what do we have? We'll have the integral of y squared dy dx. Dx should be the integral of 1 minus x squared dx. And fortunately, we can do both integrals. The integral on the left will be y cubed over 3. And on the right, we'll get what? We'll have x minus x cubed over 3 plus a constant. And now we'll have to solve for y. So we'll see that y has to be the cube root of 3x minus x cubed plus a constant. And that's it. All right, why don't we try the next one? Let's see, once again, we'll separate. You'll have 1 over y dy d theta should be sine theta. Here theta is the independent variable, so we'll have possible trivial solution. Y equals 0. So we'll come back and we'll check and see if y equals 0 is a solution. 2, we'll go ahead and integrate 1 over y dy d theta. D theta should be the integral of sine theta d theta. And we can integrate that. That'll give you natural log absolute value y has to be equal to, what is that, negative cos theta plus a constant. And now we'll go ahead and solve. So integrate, solve. Here, when we solve, we'll see that the absolute value of y should be e to the negative cos theta plus a constant, and we'll write that as e to the negative cos theta times a. Here a is positive. And now we'll continue solving. So what do we have? Y should be plus or minus a e to the negative cos theta. And now we'll just say that's a e to the negative cos theta, where a should be just non-zero. So that's our family of solutions we've found so far. Y should be a e to the negative cos theta for some non-zero a. We still have to check and see if our trivial solution is actually, if this possible trivial solution is actually a solution to the dE. And yeah, we see it is. If y is 0, then this right-hand side would be 0. And if y is 0, then this left-hand side, dy d theta, would be 0. So for y equals 0 is also a solution. So the general solution we'll just write is y equals a e to the negative cos theta. And a can be anything there, even 0. All right, let's try another one here, number 3. This one is not in standard form, so remember the standard form is the y prime equals something. So let's go ahead and try to do that. If I rewrite things, I'll get 2y y prime equals negative x squared. And let's go ahead and divide. Oops, that's a y prime, not a y squared. Y prime. So y prime should be equal to x squared over 2y. All right, so now we need to separate. Now we need to separate variables, and we'll go back to where we were. I guess it was a little bit silly to put everything on one side and then move it back, but that's okay. So we'll separate. 2 will integrate. Notice that the 2y here is never 0, so no chance of trivial solutions. We'll integrate. Integral of 2y y prime dx should be the integral of x squared dx. So that means this integral is y squared, and this guy is x cubed over 3 plus a constant. And so what's this give you? This gives you now 3 will solve, and we get that y should be the square root of x cubed over 3 plus a constant. Now we have to go ahead and this problem was an initial value problem, so let's try and find our constant. What do we want? We want 2 to be y evaluated at 0, so 2 should be the square root of c. So that means that c should be, if 2 is the square root of c, c should be 4. So our solution is y equals the square root of x cubed over 3 plus 4. And that's it. All right, let's continue going here. Let's see, again, we need to put this thing in standard form first, so we could get to what? 1 plus x dy dx needs to be negative root y, and then dy dx needs to be negative root y over 1 plus x. All right, and now we'll go ahead and separate. Let's see, we'll separate and we'll have negative 1 over root y dy dx equals 1 over 1 plus x. Let's see, possible trivial solution. Again at y equals 0. All right, 2 will integrate. And what do we have? We have negative integral of 1 over root y dy dx dx should be the integral of 1 over 1 plus x dx. Let's see, so let's continue. We'll actually do the integration. Let's see, on the left, what is that? That is square root of y, if you integrate the left side, should be equal to, over here you have the natural log of 1 plus x plus a constant. So y should be, we need to square this whole thing, natural log 1 plus x plus a constant. Oops, I was wrong there. That's a negative right there. So this should be a negative natural log, and that should be a, well, the plus c, it doesn't really matter. Anyway, everything works out the same. And now let's try to, this was 3, the solve stage. Let's match the initial condition. let's see, I want 1 to be y evaluated at 0. If I plug in x equals 0, I get just c squared. So c could be plus or minus 1. Either one of those will give you a solution. All right, let's continue on. Number 5, let's skip. It's very, well, let's try one of these, okay? We'll do one of them, one of the initial value problems. Let's see. So first we should separate 1 over 3 minus y. Dy dx should be x. And here we have a possible trivial solution if 3 minus y is 0. So that's at y equals 3. So that's separate, integrate. Well, let me see. The integral of 1 over 3 minus y dy dx dx should be the integral of x dx. And if I integrate the left-hand side, be careful, you get negative natural log of 3 minus y. And on the right-hand side, you get x squared over 2 plus a constant. So we can go ahead and exponentiate everything. Let me just move the natural log to the other side. 3 minus y equals negative x squared over 2 plus a constant. That's better. Exponentiate 3 minus y should be e to the negative x squared over 2 plus a constant. So that's e to the negative x squared over 2 times a constant a. So then we should go ahead and solve for y. And we get y is equal to, let's see, that's negative a e to the negative x squared over 2 and plus 3. All right. And then we should solve the initial value problem after that. All right, let's try number 6 here. And then we'll try number 7 after that, and then we'll be done. So in number 6, it's the exact same thing. I'll try and separate variables. So I'll have 1 over p minus p squared dp dt should be equal to 1. 2, we have to integrate. So we have the integral of 1 over p minus p squared dp dt dt equals the integral of 1 dt. And now you need to think about how to do this. You can do this using partial fractions. And that's a quick aside. Now you need to remember how to integrate using partial fractions. I'm going to assume that you know how to do that. Let me see. Okay, so let's see. We had 1 over p minus p squared. And remember, if you're doing partial fractions, what you want to do is first factor that. That's 1 over p times 1 minus p. And what you want to do is split that into the sum of two fractions. You want to say that some constant a over p plus another constant over 1 minus p. Review partial fractions. After this, I'm just going to assume that you know how to do it and carry on, okay? So let's see. You have this guy. You want to find your a and your b so that 1 over p minus p squared is equal to a over p plus b over 1 minus p. And the way you do that, now you should just go ahead and multiply everything across. So what you want is 1 to be equal to a times 1 minus p plus b times p. And now you say, well, look, if p, that's your variable, if that's equal to 0, then 1 is equal to a times 1 plus b times 0. So that means that a has to be 1. And if p equals 1, then what do you get? You get 1 is equal to a times 0 plus b, so that means that b is equal to 1 also. Okay, so now you know that 1 over p minus p squared is actually equal to 1 over p plus 1 over 1 minus p. And the good thing is that these are easy to integrate. All right, so that's great. So that's all some scratch work going into solving this. So what do we have? We have the integral of 1 over p dp dt dt plus the integral of 1 over 1 minus p dp dt dt. That's the integral of 1 dt. All right, and now we just need to go ahead and integrate. So what do you get? You get the natural log of p. This integral is negative natural log of 1 minus p. That should be t plus a constant. Great, so you've done the integration. Now you need to solve. And I might need a little more room for this. Let me just go way down to the bottom. We had natural log of p minus natural log of 1 minus p equals t plus a constant. Now the thing you should do is try to use your log rules here. On the left hand side you have natural log of p over 1 minus p, and that's equal to t plus a constant. So you exponentiate, so p over 1 minus p is e to the t plus c, and we'll just call that a e to the t. And now you need to solve for p. You find that p is 1 minus p a e to the t, and that's a e to the t minus p a e to the t. Move everything to the left. P plus p a e to the t is a e to the t. And now you're getting close. P plus 1 a e to the t is a e to the t. And finally, p is a e to the t over 1 plus a e to the t. This kind of calculation you're going to do lots and lots of times, so you'll get used to it. It's a little involved, but it's not terrible. Okay, so let's try out number 7 here. Number 7, the only thing about it is it's not factored, right? So you have to try to factor this into a product of things involving x's times a product of things involving y's. And the way to do that, there's lots of ways to do this, but I try to do like a double factoring thing. So first I'll factor the x's in the top, and you get x times y plus 3. And I'll factor a negative 1 out of the last two, so that's negative y plus 3. And I'll factor the x's again on the bottom, so I get x times y minus 2 plus, and now I'll factor out a 4 times y minus 2. And now I'll factor again, so this is y plus 3 times x minus 1. And on the bottom you get y minus 2 times x plus 4. Okay, good. And now you are ready to go. Now you're ready to divide. So separate. You'll have y minus 2 over y plus 3. And you have a possible trivial solution at what? When y plus 3 is equal to 0. Oh no. dy dt. That's got to be equal to x minus 1 over x plus 4. Now you want to integrate. So the integral of y minus 2 over y plus 3 dy dt dt equals the integral of x minus 1 over x plus 4. Oh, oops, these should be x's. X dx. All right. And the way to do these integrals, these are not that hard. You have the same degree on the top and the bottom. I'm sorry, that keeps rotating. So you want to write this. This is the integral of y plus 3 minus 5 over y plus 3 dy dx. dx equals, this is the integral of x plus 4 minus 5 over x plus 4 dx. So then you'll end up with, this is the integral. You split this numerator into two parts. You have 1 minus 5 over y plus 3 dy equals the integral of 1 minus 5 over x plus 4. This is a dx integral. So what do you end up with? You end up with y minus 5 natural logs of y plus 3 equals x minus 5 natural logs of x plus 4. All right, and you're not going to be able to solve this one for y. So you just have to leave your solution implicitly defined. So you can't. So I just did that one. Sometimes you can't solve for y. You have to leave it implicitly defined. It can happen. It's okay. I try not to assign homework problems where that happens because that's somehow unsatisfying. Okay, so that's it on